All right, guys, we're back here, and we were talking about the Pythagorean theorem as stated here, and this was a nice construction. I hope you were able to create it without any real difficulty, but it really helps to prove this Pythagorean theorem. Now we had a nice set of numbers, which we call the Pythagorean triplets. We had what we call the 3, 4, 5. So here my side is of length 3, right? Here my side is of length 4, and here my side is of length 5. And so when I have my axes on and my grid on, it's real easy to get that combination. But every time, that's called a Pythagorean triplet because it's a unique set of numbers that are all integers which fit to the effectively a squared plus b squared equals c squared. Okay, this is a side AB squared plus side BC squared equals the hypotenuse squared. Okay. Now, so these others are likewise combinations. In fact, the first three are easy to remember because they're all just multiples of each other. You got 3, 4, 5, then you double everything, 6, 8, 10, triple everything, 9, 12, 15. So that means, okay, that I can have these sides of length 6 and 8, and sure enough, the hypotenuse would be of length 10. So I'm just going to drag these to a little bit more convenient location. Okay. This side is 4, but I'm going to stretch it out to 6. Okay. There's 6. This side I'm going to stretch out to 8. And sure enough, my hypotenuse is going to be 10. Where am I? There we are. Okay, because 6 squared, 36, plus 8 squared, 64, is equal to 100 squared. Okay, 100, which is, this is got stretched out a little bit further. There we go. Okay, so that's one triplet. You also have that 9, 12, 15. So if I could stretch this out to, and at some point here, I guess I'm going to have to do a zoom out so we can see those boxes. So I'm going to zoom out here a little bit, okay? All right. So there we go, zoom out. We're going to try to get this one, that 9, 12, 15. So, I'm going to move these to convenient places so I can get a length of 9 along here, okay? So we're up to 8, right? We got to get up to 9. Should snap. Yeah. And since the zoom out, it might have a little 9, 12, 15. I think we're pretty much right there. Okay, here we are, 9, 12, 15. Okay, 81, 9 squared, okay, plus 12 squared, 144 is equal to 15 squared, 225. Okay, what is this 5, 12, 13 combination? Okay, I'm going to shrink this down to length 5. All right, 5 squared is 25. 12 squared is 144. Okay, 144 and 25 is equal to 169, which is 13 squared. So here we're going to pull this out to the 5, 12, 13 combination. All right, and it might help if I actually zoom back uh, and maybe I could lock that in a little bit better. So we're going to 5, 12, 13. So we'll pull that right there. That length is now, should be 5, yeah, 12, okay, and 13. There you have it, 5, 12, 13. 5 squared, 25, 12 squared, 144, okay. Remember there's the polygon 1, the 12, the square with built on the side whose length is 12. There's polygon 2 built on the side of length 5, and there's polygon 3, and this is our computation, if you remember, polygon 1 plus polygon 2. So there you have those nice combinations. I guess we have to show you this 8, 15, 17. All right, so I'm going to pull this out to length 15, and this one will go to length 8. So I guess I could bring this up a couple more units. 6, 7, 8. There we are. Snap right in place. Of course, what happened here is we can see Uh, I stretched this out a little bit too far. Okay, so I'm going to grab it and pull it back so that it's of length 12 now, right? Okay, 5, 12, no, 8, 15, 17. That's what we were after, right? So here we go. Bring this back to 15, and there we have it. There we have our 8, 15, 17 triangle. Okay, 8, 15, 17. And, 8 squared, 64, 15 squared, 225, and 15 squared plus 8 squared, 64 plus 225 is 289, which is a Pythagorean triplet. So there's your Pythagorean triplets. If you recognize them, then it can actually save you something on uh, the formula when you have to implement it. There are a couple more. See if you can find them. In fact, every one of these has multiples, just like the 3, 4, 5. We can go 30, 40, 50. That's a tenth multiple of 3, 4, 5. We could do the multiple of 5, 12, 13. You might want to try that. 10, 24, 26. You could do the triple multiple of that if you wanted. That would be 15, 36, 39. 8, 15, 17 has a another multiple, 16, 30, 34. So those are nice things to remember. Might save you some work with the Pythagorean theorem. Okay, there you have it.